Hello guys, my name is Angel and welcome to another episode of Dev++. Today we're going to be talking about system design, specifically about caching strategies. So let's get into it. So we're going to be talking about caching strategies for web applications and web systems. We're going to be grouping them into front-end, back-end, and data storage. So let's go through the slides, right? First of all, this is kind of like an overview of what we're gonna talk about what is the cache concepts in web application, cache strategies in web applications, front end, back end, and other types of cache that we're not gonna cover here. Are gonna be DNS or domain name services or ISPs or CPUs or GPUs type of cache systems. Okay, so let's go through this. So first of all, like a brief explanation of what the cache is any type of hardware or software that stores data with the purpose of making the access to that data faster, right? And be really conscious about the word faster, because everything that you put in a cache, it has to be faster. That's kind of like the most basic purpose that the cache should fulfill, right? Data could be stored for multiple reasons. One of the most popular reasons, maybe the most popular reason for having a cache, is as a result of a computation that takes a long time, right? So sometimes you do, like payroll calculations or things that are similar that take a long time, where you know that the input variables, they don't change and the results are going to be the same. You can put that in a cache and access the result directly from the cache instead of doing the calculations all over again, because this may include like pulling data from one database to another database, cross-reference data, add up, do an average, and those type of stuff, right? What I will say the second most reason for using cache system is network latency, right? Things that go through a network, like loading a web page or loading like a big image or CSS files or HTML files, that takes a long time depending on your the speed of your connection or the size of the file. Those are usually a very good use case for cache resources. Some really important concepts about cache systems, right? First of all, the key. The key in this context makes a reference to whatever you set up as a unique identifier for the data that you're storing in the cache system. So let's say that, continuing this example for the payroll system, if you want to calculate or if you want to store in the cache system the payroll, you probably want to include in the key the company that you're calculating from, the employee maybe, or the list of employees, or maybe the dates that you're using for calculating that payroll. So that way you can uniquely identify that piece of information. The second concept that is super important, as I told you before, it has to be fast or faster, right? It doesn't make sense that the access or the data transfer from your cache to your application takes longer than the calculation itself, right? It's just common sense, that part there. It has to be resource efficient. This ties up a little bit to that it has to be fast or faster. It means that whatever you're going to impose as a cache system, it has to perform better and be, in some cases, more cost efficient than increasing the capacity of your current calculation or of your current or normal storage without the cache system. So just to give you an example, right? If you have a heavy and intensive data application, you're doing a lot of calculations on your API or in your database, right? If you're going to impose a cache system, if you're going to put in the middle a cache system, the cache system has to be less expensive and less troublesome than doubling the size of the database, which it will give you some performance, right? In the case of if the computation is the problem, if the network latency is the problem, maybe you should look at other solutions as well, right? Hits, the concept of cache hits is simply a metric of how frequent or how many times do you access a specific key, right? That can be measured within a time frame. It could be measured within any specific events, but it's just a metric that system analysts use for identifying bottlenecks or more ways of gain efficiency. The storage of the cache system, that's also very important, right? Many cache systems difference themselves from where do they put the data, right? Whether it could be in the browser, on the local storage, session storage. It could be on their servers. It could be on a CDN. It could be on a server that is close to use, just like a replication similar to a CDN. It could be in memory. It could be on a faster database than the current database you're using. It could be on a file. That's also one of the concepts that is really important to take a look when you're evaluating or looking into cache solutions. Cache population refers to the strategy that you use for filling the information on this cache, right? Usually there are two types of ways of populating the cache. One is on demand. Basically, if you do a calculation or you request a file, the first time the files comes directly through the network, or the calculation is done, plain and simple, and then you store that with a key under the cache system. So the next time another user or another client makes a request or requests the data or requests the file, the data is already there in the cache system. Another way to do it is an eager strategy, where you start, you conceive like a policy or a way to figure out all the possible keys for the cache system, and you figure out, hey, I want to put populate everything in the cache system, so the next access or the first access could also be as fast as possible. Or you just decide in a subsection or a section of the whole universe of information that you can put in the cache, and you just put it there first for early access, right? The final concept is cache invalidation, right? Similar to the population, eventually the cache needs to expire, right? Why is that? It depends on the application, the context, and the use. But let me give you an example with a website, right? If you're looking at a blog system, a blog website, normally, once a blog post is published to the internet, it rarely changes, right? Maybe just for adding an update or maybe change words or fixing content. It rarely changes, right? So these web platforms, they usually rely on a very heavy cache platform, right? When a user requests a blog post, it is rendered on the server, put on the cache system, or put in the cache system of a load balancer or a gateway that is in front of the website. And then the next time you access that, you just get the result of a previous calculation or a previous rendering of the website, right? So some cache system, they work with expiration times. Just to give you an example, it could be 20 minutes, it could be an hour, depending on what you're going to do. But some other systems that relied on manual or event-based invalidation. That means that when you're operating your website, your blog, and you decide to make an update to one of the articles or one of the posts, you save it, and the system tells the cache system, hey, this blog post now is invalid. Please remove it from the cache system or make it invalid some way. So the next time someone requests a post, it needs to be re-rendered again. So those are kind of like small variations of a cache system. And that covers maybe like 80, 85, maybe like 90% of the cache solutions that are there. There are, of course, other strategy, but that's good enough for you to understand the concepts and being able to implement these types of solutions. So before we continue here, I would like to request or ask you that if you are enjoying this video, please hit the like button and the subscribe for get notified of more content. Share this with anyone that you think that this information will be useful, and make sure to leave a comment regarding this content or any other content that you want to see on the channel. Okay, moving forward, some disclaimers for the strategies that we're talking about here. We are talking about certain technologies for caching. Maybe 80% of the caching strategies that are out there for web applications, but there's a lot more. And we're grouping it into front-end, back-end, and data storage for simplification purposes. But there are many more layers of communication between, web components and user servers and clients, that could yield into different classifications, right? Also, we are just talking about the most popular ones, specifically the ones that I worked with in the past, so that I can provide you experience from firsthand, right? Okay, moving forward. So let's talk about a little bit about front-end cache strategies first, right? Starting with application data cache. So basically, this is the code that you write, and how you cache calculations, components, in-memory objects that you can reuse across your system in order to make the interface faster or not to perform, excessive computation on the client side, whether it's a web browser or a phone. These are kind of like important things to take in consideration. They usually are in memory or local storage or maybe local files where you can store some things that you pre-calculated. Some of the characteristics are for this, they are volatile. They're not really important if they are lost. They're application specific, meaning that each technology, whether you're using JavaScript or you're using Java, Kotlin, or Swift, it has its own way of storing this cache. Some of the examples are, local data stores, or let's say that you're building an exchange application that you want to compute something on the interface, and then you first, you store or fetch the current exchange rates, and you store that in memory for avoid the system have to, fetch those every time that a calculation is required, right? Another example of front-end cache strategies are the file cache, right? This is a very, very common, especially in browsers, because you have the browser cache system. Basically, these are storing, JavaScript files, CSS files, images, HTML files that applications usually request through the network. And, with the purpose is that if you reload the application, if you open again the application, the system it won't have to fetch everything again from the server. It already has it locally there, and he can pull it from the the disk, your local disk, instead of fetching it from the network. Usually servers provide the time to live of these resources. Let's say that you are building your application, you are the one from the server that specified to the browser, using HTTP headers, how much time does the browser can store a file or an image in order to make it valid for the user and for the browser itself to load it into their interface instead of fetching again from the server. It usually uses the file as a single unit, so you can browse on your computer the cache of the browser, and you will see that exactly as you see it being rendered on the browser interfaces. Some examples of this, of course, the browser. Some old applications that they load from the operating system, like Java applets. They use bytecode. They store that locally too, with some caching strategy. You also have examples like if you're downloading a heavy app store game. Usually they provide additional files that you have to download in order to use the game. Usually those files are stored in your phone, and they just change it based on an event, right? They just send a message to the application saying that the current file that they're using is not valid, and they need to download a new one, right? You have API data cache. This is also application specific. This entitles different ways that your application stores the data locally in order to not to fetch data again from a network interface, such as as a REST API or web services, right? This depends a lot on which libraries are you using, or if you're implemented it yourself. And the purpose of this is basically save network requests. A good example of this is the GraphQL Apollo client, right? Where you can make multiple requests to the server, and the same local client that you're using your JavaScript code, if he finds out that you're doing the same request over and over again, he just stores the data. The next time that you do that, he just pulls the data from the cache system instead of making a network request. Okay, so that's for the front end, some caching strategy for the front end. So for the back end, and again, keep in mind that I'm grouping these caching strategies from the point of view of where they are implemented, not from where they are being used or consumed, right? Not from the user perspective or client's perspective, right? So in the backend, we have site caching. If you remember a few minutes ago, I talked about blog sites that they use site caching in order to not to recompute pages on their system. If we put it on perspective, usually what a blog engine does is that you request a URL that maps into an entry on a database. He fetches the entry and he just renders the HTML. So usually the site caching is to prevent all that loop between identifying the key, finding the post in the database, bringing the post, and rendering. He just renders the site, store that site associated to the identifier of the post, and then he just brings the HTML, right? This can be done in multiple layers. It could be done in a load balancer. It could be doing a content delivery network, which is basically an infrastructure where you put servers in multiple places of the world. They mimic the website, and they just store some information there to avoid the user to hit like a centralized server. Some of the characteristics of this type of cache systems is usually a low time to live. It's based on an HTTP request, so the information that the HTTP request is using for pulling the site is already there. WordPress, the WordPress engine, it uses a micro caching strategy. Also, more complex applications and platforms like the Next.js framework, he pre-renders pages in the server or parts of the page in the server, so that way when you're doing a request, it doesn't take that much time into providing like the full response to the request. On the backend, we can also find API caching. Basically, it pretty much looks like site caching. So instead of you hitting a server for computing a number or data, the load balancer or an application layer balancer on top of the server, it takes care of storing that somewhere. So if someone does the same request within a period of time, it just pulls that from the caching system. Remember, it is very important for implementing this caching system that if you're not using an already built solution, if you want to try to build your own, which is not hard, you use a very efficient storage solution. Because if your web service is just like pulling data and doing like aggregation or grouping into your code and returning that doesn't really take that much time. And if you're going to replace that by another database, which is not the most efficient one, pulling keys and values, then it just doesn't make sense. You're not going to save that much time. Probably you're better figuring out like a different way or a different part of the system where you can, optimize. For this specific API caching, you have AWS API Gateway, you have CloudFront, you have Cloudflare, many applications that you can define strategies for populating that cache and using that cache layer. You also have in a lower level service caching, basically service functions and business logic that it can use either faster database than actually doing the calculation in memory. In memory caching, that's also valid. And also a very important concept of distributed caching, which means that usually when you build large applications, you have multiple servers, receiving requests, just because that's the way that you scale large applications, right? So if one of the servers receives a request that it has to be cached, right? You store that information on the server, but chances are that when someone else is doing the same request, it's going to be served by a different computer. So that way you don't really save time unless everybody has the same cache, right? So that's where the concept of distributing caching comes into place, right? This distributed caching could be done, is usually done by a expert system or system that is built for that purpose, where the system is connected through to all the servers that you have in your infrastructure. So when something is stored on a cache, it is made available for everybody in all the servers to read that cache, right? Some of these are database applications that are very efficient into key value type of storage or key document type of storage. And one that is super popular is called Memcache, which is an application that was built as a simple database, a very fast database, and it grew to become one of the most popular services for storing in memory and distributed cache data, right? So this system, it has a storage, of course, but it loads in each one of your servers, and it runs all the data in memory for you to be able to access this. And when you put something on that cache system, it automatically connects to all the nodes on the system, meaning all the servers, and pushes the data across the whole infrastructure, right? So that's a very good way and very efficient way to doing cache. In a more lower level, this is not that common for you to manipulate. Usually because these solutions are very hard to build manually, and usually infrastructure providers, they already provide a solution like this. But you have distributed files such as like S3 buckets for Amazon. They have built in something that is called the Amazon file cache, that if you start like accessing from different parts of the world files that are really heavy and they are under this file cache policy, he just creates like copies that are closer to you in order to make those downloads faster, right? Another example of distributed files could be peer-to-peer, right? The peer-to-peer communication, such as the BitTorrent protocol, right? The BitTorrent protocol, what it does is split the files in pieces and it starts storing copies of that file within nodes, right? That way, when you start like asking for a file in one of the nodes, you just have to like search for the pieces nearby, right? Also, very common data storage implementation of cache system are what databases do, like MySQL or Postgres. They usually load indices for tables on memory in order to access those pieces of data more efficiently. They have they create like a file backup in case the database shuts down. But whenever the server is rebooted or it loads back again, he puts those back into memory in order to access them faster. So this is it. This is the end of the episode of today. Please make sure to leave your comments if I make any mistake, or if you want to see more videos like this. We'll appreciate also the like, the share, and the comment, and the subscribe if you're enjoying this type of content. I appreciate it. I hope to see you next time.